Okay, we've got some Doppler practice here. Let's look at the problem. A stationary motion detector, important, stationary, sends sound waves frequency f toward a truck approaching at speed s. What is the frequency of the waves reflected back toward the detector? And we're given that speed of sound in air is given as c. So a couple things happening here, right? This truck is approaching the detector, and so the truck is going to, first of all, encounter the sound waves as it's approaching the detector. And then the truck is going to act as the source when it reflects the sound waves back. So I'm going to do this in two parts to hopefully make it a little more simple. So first of all, we're going to find the frequency encountered by the truck. Remember, the truck's in motion, so it will be experiencing a frequency that is greater. It's in motion and it's headed toward the detector. Toward the source. So it's going to encounter a frequency that is higher than the source's emitted frequency. So think about this. This is a stationary source, and it's a moving observer, and the observer is moving toward the source. Okay. So let's find that frequency. I'll call that f prime. The emitted frequency, that's given to us as capital F. And now we're going to apply Doppler. So you ask yourself, is the observer moving? In this case, yeah, the observer is moving, and it's moving toward the source, which is going to result in an increase in perceived frequency, right? Um, and the denominator is is the source moving? The source is not moving there. So that can just be a c there in the denominator. So I can simplify this if you want as like f times c plus s over c. Okay, remember we choose the positive sign when we're substituting an s because the truck is moving toward the source of the sound, right? The observer is moving toward, and that's going to have the effect of increasing the perceived frequency. Sometimes students will commonly ask questions about like, how do I know what signs to choose? That's why I'm going to keep on referring back to staying conceptual with that sign choice. So that frequency, this frequency encountered by the truck, that now becomes the source, right? So now the truck is the moving source of sound. And the detector that's stationary is the observer. Yeah? And then so the source is moving toward a stationary observer. Cool. So we got to think about this now, kind of flip it around. And I'm now trying to figure out what is the frequency that the truck then sends off. In other words, what is the frequency that the stationary motion detector will then intercept? And I'll call that f double prime. So that'll be the truck frequency, the frequency that the truck encounters, f prime. That's the same frequency that the truck will be emitting, right? And now applying Doppler, you have to ask yourself, what is the observer doing? So now the observer is the motion detector, which is stationary. So there's nothing to add in the numerator there. And what is the source doing? Well, the source is moving. It's moving toward the observer. So that's going to have the effect to increase the perceived frequency. Therefore, since I'm in the denominator, I subtract instead of add. Now f prime isn't given, so we need to substitute in our expression from above for f prime. So f prime is capital F, which is given, c plus s over c multiplied by c over c minus s. So that simplifies to simply c plus s over C minus S. So the kind of cool part in this problem is just keeping track conceptually of what's going on. When you use Doppler, that's often the biggest part of the problem. Obviously, using the equation itself isn't very complex, but knowing what signs to choose and then keeping track of what body or what in the particular problem is the source and what aspect of the problem is the observer, and know that like in this problem, sometimes they switch.